Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at not your run-of-the-mill pivot set, that's for sure. This is an H117-3/4, and if you're familiar with Rixson pivots, you'll be familiar with that. It's a center hung pivot for quite heavy doors, but there's an SPLO number there, 3613. What does that mean? Well, let's just cut to the chase. Here's your H117-3/4. Okay, if you're familiar with this, it's meant to be dropped down into a bed of mortar of concrete. Okay, that's what that's meant for. The SPLO value, the 3613, however, is a specialized arm. The specialized arm is intended to operate more like a revolving door. Okay, so what's going to happen is this arm, and I'd have to get my rubber mallet and pound that on there because of the paint, but that's going to act like this. It's going to allow it to turn 360 degrees. Okay, it's for quite a heavy door. So the bottom arm itself, and by the way, this weighs 12.7 pounds, the entire pivot does. So that's what this is for. And I'm going to show you as much technical information as I have available to me, specifically the template, maybe a job file from the client who ordered it. Unbelievably, there were 6 on this project. So there must be obscenely massive and heavy doors that are just all revolving around a vertical axis of pivoting. So let's just complete a visual tour of the material, and we'll take some dimensions as we go along. So let's do that now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so we have the bottom pivot assembly, and what's here, people have called me up and said, well, what in the world is that for? I had one fella tell me, well, I'm just going to remove those and I'm just going to screw it down to the floor. Well, I called Rixson that one time. This was many years ago, and this can be unthreaded. And basically, the gentleman whose name was Mike Wells, who was technical support at Rixson at the time, I do believe he's retired now, and he worked at Rixson in the 90s for sure, the 2000s, and he was their lead engineer as far as I know. Really nice fellow, and he said to me, Rich, would you really want your 1,000-pound door being secured by 4 wood screws? Do you really want that to be the case? And of course, the answer to that generally is no, we don't want that. But I know it's been done. So generally, what would happen? Not generally, what would happen is that there would be a preparation made in the floor. There'd be a concrete box or a cement box or a mortar box that's built. You'd get mortar inside of there and you'd set that down. You would make sure that it was completely level in all aspects. You'd make sure that it was completely true plumb level and square in terms of where your top pivot's going to come down right to the center of that spindle, and you're in business. So just some dimensions for scale. The floor plate is about 5 inch by about 5 inch. Well, by about 5 1/4, I should say. Overall height looks like it's about 3 inch. Overall projection of the spindle, or the height of the spindle, is about 2.5 inch. Now this monstrous arm, this would be the bottom. This is what would be facing the floor, obviously. Overall length of that arm, 9 inch. Width, about 1 5/8 inches. Height, about 1.5 inches. This is what would be called a side mount. Side mount? Bear with me. Yeah, side load, not mount. It's side load. There's end load and there's side load. So an end load means that you are literally attaching the spindle, and it pertains to overhead closers and whatnot, through the end or the edge of the door, and this would literally be prepped and then this securing plate would be right on the end. This is more like the Rixson 587 arm in the sense that it's side load, which in many applications it would be appropriate to have a side load arm, because imagine in your mind's eye a wood door, and a massive wood door, 600 pounds. Relatively, in the world of lead line doors, relatively light. So you've got a door that's already impossible for two people to pick up and move around. You've got something epically heavy. You can't prep the edge of your wood door. You can't hog all that out, okay, up at the top. That's not how it's done. Because your pivot point, I mean, that's 9-inch. Let's say that that's in the center at 4.5. I didn't measure it, but it probably is. Imagine hogging all of that out of your door. Well, you wouldn't do that. What you would do, though, is you would notch the face of the door just big enough so this plate can come off, so that when you get the door in position, you can get this connected to the bottom spindle, and then you just tip it up in place. When the door is 90 degree, so your jamb in this case is here. Let's say if it's here, and this is the doorway, so that you can then get up to the underside of the header, and through that walking beam pivot, drop that pin down and secure the door in place. It would never work with an end load, because you would literally need to be able to take the door and tip it in place this way, assuming that was even possible. Is it possible? If it's a closer, it's awfully difficult to do that, because what you need to do is take the spindle on the closer, then crank it, then put the door on it. I've had people call and say, you know, you sent me this floor closer, and every time I close the door, the door opens back up. And I say to him, well, what orientation did you install it at? Well, 90 degrees, that's the only way I could get it on. And I said, sure, you've got to take the spindle, and you've got to rotate that 90 degrees before you fit it on. And once they timed it correctly, it worked. It's, you know, it's funny in a certain. It's funny after they figure it out. It's funny, I suppose. So the side load is required because many instances you can't get to the end. And in this case, I don't recall the project. This order was literally 4 months in the making. If they're 60-inch wide doors and the pivot point's in the center, you can't do an end load. Imagine manipulating the door 33 inches or so to get the spindle engaged to the arm altogether. So side load is what you do. And then it's a wood door, so what will happen is you will literally make a removable panel of a patch of wood. You'll carefully cut that out, and that will become a removable panel that will go over this. And what you might end up doing is using a small amount of hook and loop tape, Velcro, however, to get that on there. Generally, when it's aluminum storefront, there'll literally be a piece of like 30 thousandths or 60 thousandths aluminum put right over that with a couple of screws. And that does tell someone, that's the service point. That's where I can get to the arm. It's generally overhead concealed closers, but the concept is the same, end load or side load. So this is like the Rixson 587 in the sense that it is a side load, where you load it to the spindle from the face of the door is how that is. Now, this is the floor plate. This is just a piece of finished stainless. Give you some dimensions of this. Width, again, about 5 1/4. Length, about 6 3/8 or so. Probably just, 40 thousandths stainless is what I would say. Rixson logo on there. Unfortunately, that logo continues to get bigger. I do like my corporate advertising a little bit smaller. Then we have the top pivot that I had mentioned. Walking beam pivot has everything to do with the fact that there's a screw that's here, and as I rotate that screw, if you watch the top pin, I don't have a screwdriver here, but when you watch the top pin, I might need a screwdriver. Yep, bear with me one moment. Okay, So when you get that door in place, you're going to want to be able to get to the header where you can take your slotted screwdriver and drive that pin or run that pin. You can see that I'm drawing the pin up into the housing. So when you get this installed, you're going to draw that pin all the way up. Like that. Tuck it back in there. Now in the old days, in the old Rixson days, 1920s, there wasn't a walking beam like this. There was literally just a hole in here where you would need to insert a flat bladed instrument like this to forcibly push that spring-loaded pin up. And a lot of customers in the 2020s, they would call and say, how do I get that top pivot off? So you see that little hole? You got to stick something up in there and push really hard. Someone's got to control the door while you're doing it. And the majority of the time, the people can, at long last, get it out, get it free. I had one customer in the panhandle of Florida earlier this year need to take a Sawzall to it. So what we were doing was rebuilding a Rixson Duo that he had in the floor. It may have been a Junior. In order to get that body out of the floor, had to get the door off, and that pivot had to come out. So he Sawzalled that. We then rebuilt that Duo or Rixson and then sold him a new top pivot that he had to marginally mortise, but it was brand new. He'll get another several decades of service out of the installation at that point. So obviously before you do all that, you'll have the door portion mounted to the door itself, and you get the concept of how that's going to work. So let's take some basic dimensional properties of this. The door portion, about 7 1/4. Overall width, about 1 1/4 or so. Thickness, it's probably 1/4 inch. Yeah, maybe 5/16. The header portion, it's going to be close, if not the same. 6 3/4, 1 1/4, about 1/4 inch. Then for the header portion will be a finished plate. It's going to be available, of course, in all of the different architectural finishes. This order was placed as 652, which means satin chrome is what it means, but it technically means plated satin chrome over steel with a lacquer applied. The finished plates here they're stainless, but the factory's not calling us to say, hey, we're not going to do it in 652. Is 630 okay? It is. The fact of the matter is they're probably doing everyone a service by using stainless, because solid stainless with nothing but a brushed finish is the most durable of all finishes, where 652, or you might know it as 626, that's plating. That's something that can wear out. Now, you're not really going to touch the floor plate like you would a push plate or even a kick plate, but the fact of the matter is this would end up being the most durable of all finishes. Now, before we move to the screen view, fasteners, these would be for the arm. Thrust bearing would be here. You're going to need that. That's going to go over the spindle, and the arm will sit on top of that. We'll touch on that when we get to the instructions. Machine screws as well for the arm. I don't know if this is a wood or a metal machine application. Screws for the finished plate on the closer body. Screws for the top pivot assembly. A couple of shims. Hopefully you don't need those at all. Maybe there's 3 of them in here. A couple of flathead. Oh, these are the 2 fasteners for the finished plate on the header portion of the top pivot, and then an Allen wrench, and that will be for the screws on the side mount version of this arm. That's what that is all for. So let's switch to the screen view and let's dive into all of the paperwork. Here it is. We'll take a look at all of this and we'll analyze everything that's happening here. So let's do that now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, let's dive in and take a look at all of this supporting information that we have. First of all, this is an extremely unusual pivot. I really don't expect to sell very many in an entire career, but Rixson does a really good job when it comes to taking a custom request and figuring out a solution for it. They have somebody in design who's basically in engineering as well that's making sure things work the way they ought to. So let's take a look at. So let's start with what a typical H117 would look like. I mean, H117 is it's all the same stuff with the exception of it having a far less potent sized bottom arm. This happens to be an H117 with the 587. It's still a giant arm, but not 9 inches long. 1,000-pound rating on a typical H117. There's a video of mine, probably not unlike this one, reviewing it. And the point of bringing you to this is to simply show you the cut sheet that exists. Okay, you get an idea of what it looks like. Basically, it's an arm that's almost double the length, depending on, well, based on the application. So that's a cut sheet. Then we're going to have the product catalog. You can look at that if you want. Template, we're going to go over the specific template for this variant, so we won't bother with this one. Installation instructions, that's generally the same thing as the template. There's nothing here really beyond dimensions that you need to know. We're going to keep this up because I think we'll want to refer to that. Instructions, that might just be a duplicate. Something different showing where that bearing sits. Giving you an idea of where that bearing sits. All right, let's look at some images that we have here. That's the label on the box. That's the business end of everything. Those lugs, they have been curved in the past. I don't know why they changed that. Curved, they found, gave better pull resistance, but curved may have caused too many customer service calls that the product was damaged. I can't say for sure. There's our arm. That's the side that goes to the bottom of the door, as is this. That's the bottom side. Okay. Let's look at some additional photos. These would be of the top pivot assembly. Your adjustment screw. Your door arm. The underside of that. Pardon me, the top side of that. You won't see any of that when it's installed. All right, let's also take a look at the last couple of images. We have the cover plate, along with all of the several and many screw packages. Machine bolts, shims, top pivot, thrust bearing, Allen wrench, cover plate for the header of the top pivot, and then some wood screws. Now let's take a look at the documents that pertain to this job in the sense of, so this is some documentation from the client. This is what these are designed for. Wow. So a 6-foot wide door, tempered glass, (102 inches tall. That's going to rotate like a revolving door. That's pretty epic. 6086. 1, 2, well, 3, 4, 5, 6. 6 of these openings. I don't have a floor. I was about to say I don't have a floor plan, but I don't. I don't know if there's any. Yeah, is this it? Opening. Yeah, I would say that this is definitely it. This is important to take a look at as well. Here's what the client's building. Channel, 1/4-inch bent aluminum plate, gasketing, big piece of glass. They're going to assemble that around the glass, obviously, probably weld the frame closed. Prep all of the hardware. Yeah, that's your top pivot assembly. Another view of that as well. They would have done a lot of engineering on this. That is showing the bottom pivot. The people at this company would have drawn all that in AutoCAD. They would have had drawing. They would have had the template, which is here, and they would have mimicked all of that. They would have drawn all that. Yeah, really fascinating. cross section, elevation view. That's what they're showing us here. You know, so the bottom line is you can see what the client has in mind. The bottom arm, it'll all be machined, drilled and tapped. Your glass will sit in there. So pretty, you know, really fascinating stuff. You know, I don't recall if there was any conversation about exactly how heavy the material was. Again, these conversations were 4, 5, 6, 7 months ago. Really, really great stuff. Let's now get our zoom set back to where it needs to be. Hardware set. Let's take a look at what was called out for the hardware. Okay. Okay, let's open that. Let's rotate that. Let's zoom it. Group 6, H117-3 SPLO 6313 configuration. Floor hinge, top hinge, custom poles. Provide automatic closer. Allow door to be rested in an open position at 90 degrees. Well, we know how to install that now. That's easy. I don't know what they're doing for a closer. I wasn't brought into that part of the conversation. It could be a situation where they have an overhead closer. I don't see it called out anywhere. I don't know what would be doing the self-closing on that. Yeah, nothing up in the header. So these are manual doors, is just the bottom line. So that's our hardware set. Now let's dive into the meat and potatoes of this paperwork. And these, I love these drawings, and I love them because they're elegant in the sense that they're everything that you need. You don't need anything else other than this. You really don't. And let's go over why. All right, let's dive into this. So, first of all, if you're new to seeing this or something like this, don't let it intimidate you. There's more information on here than you might need. I don't know that there's... I mean, unless you're building the door and frame and installing the hardware, you don't need all of these dimensions. If you're the hollow metal guy, you need to know where all the screws are located, or the aluminum guy, so you can drill and tap and put your reinforcements. If you're the guy mortising a door for this, you don't need to know where the screws are located as much as you need to know the length of the arm, 9-inch, the height, the thickness of the arm, which is here somewhere, 9-inch. Aha! Something fun here as well. Okay, so 1 3/8 tall, 9-inch wide. Okay, here we go. It's 1 3/8 wide, 1.5 inches tall, 9-inch in length. So now you've got the idea. The other important, the first thing actually we should have done, it's 5-inch over, dimension from the heel edge of door to the center line of the pivot. So they're clearly drawing a radius here. The question is, I don't know what that radius is. And I don't immediately see it drawn here. The issue, though, is that all would not really be lost, especially for this client who drew all of the details that they drew, in the sense of you'd have to figure out how you would treat the edge of that door. They're clearly not radiusing anything. The question becomes is, how did they determine? How is it that they determined 6 foot 1 inch for a 6 foot wide door? Door width 6 foot 1. How'd they come up with 5-inch and a 1/2 inch here? How did they do that? I don't know. It is not clear. However, It certainly needs to be rendered clear. Service that we provide is helping customers determine what needs to be done for something like this. So using AutoCAD is something that we do in terms of helping customers figure out what needs to be done. So what I'm doing is setting my grid lines. I'm going to set my major lines to 4. So what we have now are major lines, and that each of these is a 1/16 of an inch. I could make it a 32nd, so this should be a 1/4 inch by 1/4 inch. Then what we're going to do is let's set our origin point. It doesn't really matter where the origin point is, but what we're going to, I use the origin point to just give me a point of reference. So here's what we'll do. Let's quickly draw a jam and trying to determine the jam width. I don't know if there's a wall section here. That will easily give me that. So studying this a little bit further, you know, our door is only going to be that channel size, which is 2 inch, 2 by 2 by 1/4 inch. What you're seeing here are the pull handles that are installed flush to the edge of the door, or at least inferred that they're flush. Well, that's certainly not going to work. But the bottom line is we don't need AutoCAD to know that a 1/2 of an inch here for a 2 inch thick door is going to be enough being square edged. And we can quickly draw that. So let's, well, quick is relative. So we'll draw a polyline starting at our origin. We're going to start at 0, 0. Enter. That jam looked like it was about, you know, 8.5 inch. Oops. 8.5. 8.5 and 90-degree angle. 90. Okay. Then we're going to say that that jam is, you know, 1 inch. Okay, then we're going to come down, I think I said 8 1/4. Yeah, 8 1/4. Oops. 8 1/4 and then 90. Alright, so we've got a jam here. Roughly 8 1/4. Now let's draw a polyline x-axis to the center line of 8 1/4 would be 4 1/8 minus 1 inch because the door is 2 inch thick. So it'd be 3 1/8. So let's say from our x-axis, let's go over from our y-axis. This was 1 inch, so we're going to come over 1.5 inches. Okay. And then, oh, that's not what we want. We want to have our polyline at 1.5 inches, and then 3 1/8, I think is what it was, right? Let's say, well, that door was 60 inch. So 60 at 0. Then we know that it was 2 inch at 90. And then we know that it was 60 at 180. Right, and then it's going to be 2 inch at 90, and that's going to be our door. It should be drawn in the center of that opening. Okay, this should be 1/2 inch. Measure 1/2 inch. Yeah, we're good. So now we're going to rotate. However, where's our pivot point? Our pivot point, our vertical axis of pivoting, is 5 inch from the edge of the door. So it's going to be 5.5 inch off the jamb, or 6.5 inch off the y-axis. So that's 0. So let's rotate. Select your object. Got it selected. Enter. Specify your base point, which would be 3. Eight and a quarter. Is that what I forgot what the measurement was? Let's quick. 8.5 is what it is. So 4 1/4. So it's going to be at 4 1/4. So rotate. Select the object. Enter. 4 1/4. And then it's going to need to be at 5, 6.5, right? Yep. No, that's not right. I got something wrong there. 5 inch. Let's try it again. Rotate. Select the object. Enter. 4 1/4. Zero. Two inch, 1/2 inch, 1 inch. So 1 plus half, 5 inches over, is 6.5 inch. So rotate. 4 1/4, 6.5. All right, I'm coming up with something wrong here. Okay, I see what I'm doing wrong. I'm entering the coordinates in backwards. So it should be 6.5 and then 4 1/4. Yeah, that's what it is. Okay, so now we can really see that door move. So the question becomes is how much room do they really need? You know, if we kind of study how close that gets, looks like it's about at its closest right there or so. But we can just get in here. We know that this is a 1/4 inch, our two major lines, and that's 1/8. So 3/8. So the truth of the matter is they really, you know, they don't need more than a 1/4 inch is the bottom line. That's how I would determine it. Hope that was of some value to you, in spite of the fact that it was, I beleaguered the drawing portion of it. So now we know what our margin needs to be. We certainly know that a 1/2 inch on either side is more than adequate. We know where we need to place the vertical axis of pivoting, 5 inch from the heel edge, 5.5 inch from the jamb, the way it's drawn, however you're going to calculate that. You know the length, the width, and the height of the bottom arm. You know where to place it. Now, here's the important part. One inch minimum from the bottom of the arm to what is the bottom of the door would be my guess. Yeah. So let's step back. Next question becomes is how large is your door? What's the height? How do they, how do you determine your rough opening height? Or your finished opening height? If we're going to say that this is the bottom of the door, which it is, 1 inch to the bottom of the arm, another 1.5 inches, that door's got to be prepped in 2.5 deep. So they're not giving us a clearance. The sill or the floor to the bottom of the door. What they're telling us is that the arm must be installed deep at least 1 inch. So if your opening was 8'6", 102 inch, you're going to leave an 1/8 of an inch margin at the header, let's say, maybe a little bit more, but not much. You're going to figure out what your clearance is. Let's say it's 1/2 inch. So if your finished opening is 102, you're going to need an 1/8 at the header, and then you're going to need a 1/2 inch here. So now you're at 101 and 3/8 net door height. You know that you've got to have at least 1 inch clearance plus the 1.5 inches. So that would be the math to go about figuring out what your net door height needs to be. You're going to inherit a finished opening, and you'd have to derive what's my net door size, the width and the height. The bottom line is, so long as you maintain a 1 inch minimum, that clearance can not be anything. Actually, I would severely question that. This dimension is probably closer to 3/16, and why I would say that is because our spindle length is quite fixed from the top of the finished floor plate to what's going to end up being 1.5 inches plus 1 inch plus X. So as I measure basically this here to here, that's going to help us figure out what we need to do. That should be drawn in on this paperwork. I don't see it anywhere. So as I hold my tape measure to measure that, this would be a call to the factory. Yeah, absolutely. Interesting. It's 2.5 inch. So what's 2.5 inch is the plate to the top of the spindle. So if that's 2.5 inch, you realize that the greater clearance you have, the less engagement that you're going to have on the arm. So they're saying a 1 inch minimum from the bottom of the arm to the bottom of the door. Yeah. Okay. Yeah, that makes sense. The bottom line is, when you have a 1 inch dimension here, the spindle is going to flush off to the top because that's 2.5. So keeping this margin absolutely tight is crucial. 3/16 of an inch, something very small. But what if it had to be a 1/2 inch? What I would have done is made the spindle longer on every one of these units, and then I would have drawn it such that you had to have a boss preparation up into the bottom of the door. If your design would tolerate it. This glass design would not tolerate that. So let's say that this dimension is 3/16. First of all, with a 6-foot wide door, is that going to work? Is your floor that level? Floors are never that level. And I have to say, I'm a fan of not needing to have the hardware in your hands, but in this instance, it would have been necessary to call the factory and ask them for what that dimension is. It's not called out. If you didn't have the hardware, you wouldn't know. Floor plate to the top of the spindle is 2.5. They're calling out a 1-inch minimum from the bottom of the door to the arm, and then 1.5 inch, that's 2.5. So you won't have full engagement. So longer spindle and a boss, or, you know, yeah, okay. And plus the prepped side of the spindle is 1.5 inches. This is 1.5 inches. So the other problem with that dimension is you're not sitting the arm on here. You're not yeah, well, I want to see where that thrust bearing sits, so bear with me. Yeah, it sits down there, but if your arm is not making contact all the way down with the bottom of the spindle, you're not engaging the thrust bearing. So it needs to be fully engaged. So this margin's going to be quite small. You need that to be as small as possible so that you have engagement as great as possible here.
You talk to me.
Okay. The balance of the information here is basically just your top pivot information. We already know the vertical axis of pivoting. This is the most important dimension to start with. Where are you going to put the vertical axis of pivoting? Center of door, and then 5 inch over from the edge of the door, or from the jamb, however you're doing that. They're showing a radius. They're not telling us what radius it needs to be. Using AutoCAD would be a great way to determine absolutely what you needed to have. Do not scale drawing. Provide suitable reinforcement. Pivot is non-handed. Right. However, the installation should be handed to allow access to screws from the inside face of the door only. So what they're saying is when you order this, you'll be calling out the hand to be proper because they're stating that it should be handed, but this arm can be flipped around. So it's, at the end of the day, it needs to be called out as handed, which we didn't. We should have. So that's a message, not to the manufacturer, because they know it's going to come out non-handed, but that's a message to the installer to say you're obligated to install it for a right-hand door. Okay? Because there's going to be a typical way that it swings. There's going to be an inside and an outside. It may not matter in this case, and it doesn't, because those are just pull handles on either side. So it's not the end of the world, but what I'm driving at is calling this out as a hand is what it should have been. That would have been more correct. Just some drawings of the top pivot that came from Assa Abloy at some point. Nothing really germane there. So 3/16 down here would be my guess. If it has to be more than that, it needs to be a discussion with the factory to find out what the plan is, because it's not clear. At least it's not to me. All right, let's wrap up this video on camera. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that You know, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. So to put the tape measure on what I was talking about earlier, 2.5. I don't have the plate here, but that's very thin. 2.5 inch is what it's shown here. That thrust bearing. You know, that arm needs to sit fully there. So what I'm thinking is, obviously, that shim spacer that's there has to be employed. Now, at the end of the day, someone's responsible for getting this right. Because getting it wrong is a costly proposition. Yeah, we've got it installed correctly. That link is down below as well. Yeah, see? That brings us flush. Now, okay, the question becomes is what's the dimension from the plate to that thrust bearing? And that's 1 inch. So the only way that's going to work is if you've got a small margin from the bottom of the door to the situation, to the floor, and you're going to hold that up a little bit because you're going to need to suck that up just a little bit. So you won't get full engagement in there. Who knows what they have it engineered for? Maybe they've said, no, we know that it's not full engagement. 1 inch of that 1.5 inches is absolutely sufficient. But that's a problem. This has to sit here. The only thing I can say about that is I don't see why it needs to be 1 inch from the floor to the underside of the arm. They have 1 inch minimum. I don't see why that couldn't be 3/4 inch. Because all you're doing at that point is exposing more of this. You're not meant to completely conceal it. You're going to see some of it. So your door coming down right to this top collar is probably what the bottom line is. I probably would have drawn that at 3/4 inch and drew the floor in at 1/4 inch. And probably what they could also have done was simply said, when you order these pivots, at the time they were ordered in 2022, were over $2,400 each. It should have been required that the clearance be specified, so that the length of the spindle would have been commensurate with the penetration into the arm. Is what I would have suggested. Is what should have happened. Goes back to what Mike Wells said. Do you really want a 1,000-pound door being held with number 14 wood screws? So that's where that is. It's fascinating to dive into the world of pivots, garden variety stuff. Well, that's all fun, but when you get to deal with something that's positively, on the cutting edge of what pivot hardware can handle, we've got some pivots in stock that are 3,000-pound pivots. They're really cool. Look for a video for of that in the near future. So if you have any questions on the H117-3 or any other Rixson product, please feel free to reach out to us. And thank you. So we're obviously not able to just let the mystery of the bottom of the door, the clearance issue, lay without resolution. So I've called the factory, and what follows is the proper answer. And I thank the gentleman at the factory for helping provide that. Architectural Builders Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
Good. May I speak to you about a H117-3 quarter?
Sure. How can I help you with that?
Okay. So we just received H117-3 quarters with the SPLO-3613.
Okay.
And I would like to look at that template with you because something is bothering me.
Okay. All right. Well, I will not be able to help you with that because I don't have access to those templates. I'll get you over to tech support. Let's see if somebody can walk you through that. Okay.
Thank you, ma'am.
Sure. Give me one moment. Okay.
Yes.
Tech support.
Hi, it's Rich from Architectural Builders. How are you?
I'm doing good. How are you?
Good, good. May I ask you a question about an H117-3 quarter?
Yes, sir.
So I just received 6 of the SPLO-3613. Would you please look at that template with me? I need clarification on something.
All right, let me see if I can pull that up. Okay, now 3613 is for an H117-3.
Yes, sir.
Okay. All right.
Okay. Lower left-hand corner showing the finished floor. There's that
Okay,
dashed
hold on a second.
line.
I think I may have pulled the wrong one up then. Let me pull this one up. Lower left-hand corner. Gotcha.
Okay. So there's a dashed line there. Is that meant to infer the door?
Yes.
Okay. So the unknown is the clearance, the bottom of the door to the finished floor.
We own just about everything we do. Is a 3/16, but
Yep.
what we do here, we're showing it. And I don't know why they got it like that. Let me pull this other one up. I think this one may be a little bit better. Okay. Why? Oh, let me see here. Rixson. This is going to be. This should be the same at. Just because it's just a different arm than the Okay, so I don't know what they're showing on here or why they're showing that, because from the finished floor to the bottom of the arm is a stationary 1 inch. So I don't know why they've got it going from that dotted line up. That makes no sense to me.
Yeah, and I have the benefit of the hardware being on my desk, so I apologize for that. The issue is from the finished plate that will sit on top of the body, all the way to the top of the spindle is 2.5 inch.
That's
You're
correct,
gonna
because it's a 1 inch. It's 1 inch from the finished plate to the bottom of the thing, and then the arm is actually 1.5 inches.
Yeah. So realizing that the door has to be sucked up off the, there has to be a clearance dimension.
Right.
Couple of
And
problems.
normally, like if you look at just a standard H117, and it still mounts like in the floor and everything the same way. It's just a different arm because you're moving the pivot point over, and it's equal weight on both sides because it's like a center. You're putting it in the center of the door. We do and have it set up for like a 3/16 undercut.
Yeah. The problem.
So we're actually
with,
mortising into the door at that point, like 2 5/16.
Mhm.
So
Okay.
it's basically 2.5 inches minus the 3/16 undercut.
Yeah,
And that's basically what you want to do. You just take that 2.5 inches, and whatever your undercut that you want, you just minus that off of the 2.5 inches, and that's going to give you the mortise depth that you need to set your door at.
Yeah, right. The issue though is when you trim. So the issue is that dimension, the 1 inch. That's what's causing the problem because on the template, because from the finished plate to the where the top of the thrust bearing is going to sit, that's your 1 inch, and then you've got 1.5 inches of spindle and engagement of the spindle in the arm.
Right.
So, so should we be looking at that 1 inch really as 13/16, and then 3/16?
So you can put the door, that spindle should go up inside the door if it's 1 3/4 door. So if you want to,
yeah, if
you want to hide all that,
2 inch.
yeah. So if you're, yeah. So I mean, yeah, 2 inch, yeah, and that's what this shows on here, 2 inch. So yeah, I mean, if you want to still set everything up in there, you just mortise up into the door that height, to whatever you want your clearance to be at the bottom. Because all that is up inside the door. So you have to make sure that the bottom part of your door, because a lot of times they just put, if it's not a solid core door, or if it's like a hollow metal door or something like that, you have to make sure that web is going to be deep enough to accommodate that arm in that height.
So would you agree that on the template, the 1 inch minimum, I would say let's call that X. Let's call the clearance Y, and then put a note there that says X plus Y equals 1 inch. Would you agree that would work for?
Yes, because it's a total, right?
Yeah,
right.
Yeah.
So that total from the plate to the bottom of the arm is going to be 1 inch. Yeah, that is correct. Yes.
Awesome. So the bottom line is I've spent years looking at this stuff, as it sounds like you have, and I just needed to have like minds agree that would be the approach. So
yeah, and I don't know, and I need to actually print this because that's not right, and I need to go give this to my design engineer.
Yeah.
Yeah. But yeah, because they've got it at that dotted line, from that dotted line to there is not an inch. It's from the plate to the bottom of the arm that's the inch.
Yeah, because if you maintain that, then your arm will not be sitting on the thrust bearing. Is the bottom line? Yeah.
Mm-hmm.
So because how many of these does Rixson make a month or a year? There's 6 of these on one job. My God, it's unusual. So I had the guys got to get it right when they go to install the material. So
right. Cool. Yeah. So I'm definitely going to print these 2 templates and just set it in there because that's. I'm glad you brought that up because that one line needs to stretch down to the solid line and not off that dotted line.
Yeah.
Actually, there needs to be another line from there to the dotted line that shows 3/16, which is what's on the other template.
Yeah, and so many other Rixson templates are basically they show you the clearance and the mortise depth, and you can derive. Oh, well, if your clearance is going to be 1/8 of an inch more, your mortise depth is going to be 1/8 of an inch less.
1/8 of an inch less. Yeah, exactly.
So, yeah. Hey, thanks for taking my call, and I hope you have a great weekend.
I appreciate you calling and let us know because I'm printing that out right now, and I'm going to get that over to the design engineer because that is not correct, and that needs to be fixed.
No, I mean,
guys, people get it. It's just, I
but we're gonna have people that's going to get that, and they're going to do it wrong, and then it's going to come back on us, and that's not going to work.
All right. Thank you very much for taking my call, taking the time.
I appreciate it. Thank you.
Bye-bye.
All right. Bye.
Architectural Builders Supply hopes you have enjoyed this program. So, a happy resolution to that mystery has been provided. So it's basically x plus y equals 1 inch. And let's just say x is going to be your clearance. So you're going to know that or define that. Or say, this is what I want it to be. And then you'll have the y dimension, bottom of the door to where the arm will start, as the balance, all the way to x being 1. You can have a 1 inch clearance and then your arm flush with the bottom of the door. The issue, though, is the greater the clearance, and there's two terms, undercut and clearance. Undercut is the bottom of the door to the bottom of the jamb. If you've got a concrete pour and you put in hollow metal doors and frames and you've bolted that frame to the wall and you hang that door, the bottom of the jamb, which is sitting on the concrete pour to the underside of the door, is 3/4 inch. That's industry standard. It can be anything, but stock hollow metal is 3/4 inch. Well, what happens when you come and put tile in? How do we define? Now, the undercut's still 3/4 inch. The term clearance is what's used. Let's say that you're putting in a 1/4 inch worth of tile. So now that 3/4 becomes 1/2 inch. We call that clearance. So the clearance dimension is something, as you increase the clearance, you're going to expose more of the collar and the thrust bearing. Not a big deal, but just be aware of it. So bringing the door down as tight as possible to the floor is always a good idea. But in this case, when you've got a door that's wider than my outstretched arms, okay, and I had a conversation with a client yesterday, what should I make the undercut? And I says, well, make it as tight as possible, but no floor is level, because he was doing an automatic door bottom. He called me, well, he initially called me 2 weeks ago and asked that question. He called me yesterday to order and said, you know what, you were right. When I get that door out to about 80 degrees, yeah, it's hitting, and I've got 3/8 over here, so the floor is really out. Every floor is out. No floor. And in the customer's defense was, they're concrete guys that are pouring concrete. Their intent is to get it level, but the mason, the concrete pour outfit, they're not trained in any sort of hardware installation. So the concrete guy doesn't know what the hardware guy needs. The hardware guy has no idea about concrete, so it's a bit of a misfit there. So be mindful that you want to draw that door as tight as possible, but it still needs to spin. So for that 60-inch diameter of these doors spinning, which they can spin, that floor needs to be completely level based on what clearance they're going to achieve, that they're going to decide on their door. And as you saw in those drawings, these doors are going to be absolutely fit. You're not going to be able to get under there and grind a 1/4 inch off because the pour of the concrete is gone like that. 48 inches out at a 75-degree angle. Anyway, that's enough of this. Thank you very much for taking the time. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you. Thanks to our clients, Architectural Builder Supply is building an additional facility, and what follows is not only a look at the acreage that we're building the facility on, but also first the architectural renderings as they exist, or at least the architectural plans as they exist at this time. Thank you very much. Let's take a look. All right, let's take a look at the architecturals as they exist at this moment, or at least it wouldn't be proper to call these architecturals, but it would be proper to call them renderings in the sense of they're conceptual drawings, they're not renderings. So the entire space is going to look like this in terms of a site rendering. This will be a 22,000 square foot building, of which will have specific purpose areas. There'll be a workshop down here. This is a few thousand square feet that will be likely woodworking, metalworking, CNC, things of that nature. This will be an office area here, a private office area. This will be Architectural Builders Supply expanded storage area where we will be able to do fulfillment. The entire space in the center is going to be all of the volume, as I call it. Large components will be able to be stored and stocked there. Machinery that's too large to fit otherwise may be put out here. Specific facility rooms, and then some recreation over here. Let's take a look at that drone footage, and thank you very much for taking a look.